Welcome everybody, we've been given this question. We are expected to show that f of x is equal to cos of x cubed negative x is differentiable at x is equal to 1. So we are asked to show that f of x is equal to cos of x cubed negative x is differentiable at x is equal to 1. So solution, foremost what we got to do is you will have to show that f of x is continuous. This is the first step. So for that we need to execute the following steps. That means find the functional value of f of x for x is equal to 1. Number 2, show that limit x tending to 1 negative of f of x is equal to limit x tending to 1 positive of f of x are equal. That means left hand limit is equal to right hand limit. And then finally show that the left hand limit equal to right hand limit is equal to f of x, the functional value. So foremost, let me start with finding the functional value. Of f of x at x is equal to 1. So we are given f of x is equal to cos of x cubed negative x. At x is equal to 1, we got cos of 1 cubed negative 1, which is nothing but cos of 0, which is equal to 1. So this means f of 1 is equal to 1. So that's the first step. So this in turn means f of x exists and as value equal to 1. Now let me check a limit extending to 1 negative of f of x, which is nothing but limit extending to 1 negative of cos of x cubed negative x. Now applying the limits, we get cos of 0 is equal to 1. And the next stage, limit extending to 1 positive of f of x is equal to limit extending to 1 positive cos of x cubed negative x. We apply the limits and we get cos of 0 is equal to 1. So this means the left hand limit is equal to right hand limit, and left hand limit being equal to right hand limit is equal to f of x at x is equal to 1. Okay, because that's a functional value. You see here at x is equal to 1, we got the value to be as 1. So final conclusion, this means cos of x cubed negative x is continuous. So we got that. So now we have to show the next part, which is the differentiability. Okay, so let me show you that. Now next we need to show differentiability. Show that f of x is equal to cos of x cubed negative x is differentiable at x is equal to 1. So we'll be using the definition of differentiability. So by definition of differentiability, we know that f dash of x is given as f of x positive h negative, of course limit h tending to 0, right? But our f of x is cos of x cubed negative x. So at x is equal to 1, this is going to be cos of 1 minus 1, which is cos of 0, which is equal to 1. So hence f dash of 1 is equal to, of course let me state the limit h tending to 0 of f of 1 positive h minus f of 1 divided by h. So this is going to be cos of, in place of x we will have to substitute 1 positive h whole cubed, negative of 1 positive h. Okay, so followed by f of 1 is 1. This is divided by h, of course, limit h tending to 0. Now we will have to expand this a positive b whole cubed formula, which is a cubed positive b cubed positive 3a squared b positive 3ab squared. So by that, 1 positive h the whole cubed will be 1 cubed positive h cubed positive 3 1h positive 3h squared. Now this is subtracted with 1 positive h, so this is going to be negative 1. I'm going to do the calculations here, negative 1 negative h. So that is going to give me negative these two components goes up, and I get h cubed, and you have positive 2h, and you have 3 times h squared, followed by okay, there's nothing, okay, because we are only evaluating this. So this is what we've got. So this is going to be cos of h cubed positive 3h squared positive 2h, that's for cos value, negative 1 divided by h. Now what we will do is we will utilize the small angle approximation. So using small angle approximation, we have, so what do we have using small angle approximations? So this is going to be cos of h cubed positive 3h squared positive 2h. This is going to be approximated with 1 negative, okay, let me start writing with 2h, 1 negative 2h positive 3h squared positive h cubed, okay, divided by 2. Now if we were to get rid of the higher powers, okay, so removing the higher powers or ignoring the higher powers, this one is now going to be approximated with 1 negative 2h. Now the important part here is this entire component is approximated with 1 negative 2h positive 3h squared positive h cubed, the whole squared, okay, that is critical. So this is going to be approximated with 1 negative 2h the whole squared divided by 2. So when we are rewriting, we will have this to be equal to 1 negative 2 squared h squared divided by 2, which is going to be 1 negative 2h squared. So we will have to utilize this. So hence we have this, the functional value f dash of 1 to be equal to limit h tending to 0 of 1 negative 2h squared. There is already a negative 1 here. See, there is a negative 1 here. Negative 1 divided by h, positive negative goes up. This is going to give you limit h tending to 0 of negative 2h squared divided by h gets cancelled. So applying limits, you get equal to 0. This means f dash of 1 exists. So this means f of x equal to cos of x cubed negative x is differentiable. So that's a solution, and please like, share and subscribe. Thank you.